this one, it's a projectile motion problem, and you're given the angle of launch, which is 35 degrees, and the initial velocity is 20 meters per second, and you have to find the horizontal distance traveled. So you have to start with finding the x and y components of the initial velocity. So for that one, you do the triangle. This is 35 degrees because that's the angle it was launched at. And then the total initial velocity was 20 meters per second. So the x component would be cosine 35 times 20. And the y component is sine of 35 times 20. Okay, so then you have to split it up. So first you have to do the y component. So y equals y naught plus v y naught t plus 1/2 ay t squared. And then you have to solve for time first since you're not given that. So the final y position is 100. The initial is 0 plus, and then the initial y velocity is the sine of 35 times 20. And then you don't know time, so that's still t. And then plus 1/2. Acceleration in the vertical direction is always 9.81. And then you don't know t, so t squared. So then you have to solve it like a quadratic. So you get 0 equals 4.905 t squared plus 11.47 t minus 100 when you put it into like the standard quadratic form. Then you use the quadratic formula, the negative b plus or minus square root of b squared minus 4a, or a c all over 2 of a. That's what t equals. So then t ends up being 3.49 seconds. So then now that you have t, then you can use the x component form. So you have x equals x naught plus v x naught t plus 1/2 ax t squared. So the final x position is what you're trying to find. So x equals the initial 0 plus the initial x component is cosine 35 times 20, and then t, which is 3.49 plus 1/2. And acceleration in the horizontal direction is always 0. So 0, and then t squared. So that cancels to be 0. That's 0. So x equals cosine of 35 degrees times 20 times 3.49. So x equals 57.18 meters.